I know drawing, but it's
Right. So it a drawing that conveys specific information. Okay? So if I told you that give me a sketch of a design, for example, you would be asking for a very simple detail of what it would be about. Alright, so let me give you an example. Pictorial sketches represents 3D object in 2D plane. The 2D plane being your paper or your board, for example. So the minute I start to draw any design on a board, I am sketching a 3D object, which is a real world thing, like this laptop, for example, onto this projected board. Okay? So I want you to write a definition for me on your paper. Let me screen share it again. A pictorial sketch represents a 3D object on a 2D sheet of paper. It's the most important thing. Pictorial sketches. Everybody have that down? Guys have that down?
sir, we don't use borders, right? But
No, you're not gonna do any borders. Today's gonna be just designing your paper using sketching. It's not gonna be an actual drawing we're doing today. Okay? But here's the first thing though. You're gonna write the definition of pictorial sketch, and then you're going to say there are 3 types of sketches. There are 3 types of sketches. The first being an isometric sketch. The second and third, that we're going to be learning about in a few. So let me show you back again how an isometric sketch would have looked like. So these are examples of isometric sketch. I want somebody to tell me quickly what are the 2 directions we said, or what are the 2 angles you use in an isometric sketch. What angle do you use? So let's say this is the 90-degree line. What angle is this bag going away from? Isn't it 30 degrees?
Yes, sir.
Right. Okay? So the bag is at an isometric sketch because on both sides, even though it has some fine details, you can see the projection is going in 2 directions at the same angle of 30 degrees. Okay, the next one is what I told you about last class, or introduced to you, is oblique, which we'll be learning soon. Oblique sketching. Alright? And let me quickly give you an idea as to what oblique sketching is. Just put this in your mind. Oblique sketching is the most biased type of drawing, because what it's saying is if I have this duster, took me a while. If I have this duster, right, and I want to draw it, but I'm biased to this side because this side has better detail, I guess, compared to all the other angles. Oblique drawing says I'm going to sketch the face of this duster first. I'm going to sketch the face of it, and then everything is at a 45 degree from it. Okay? Everything is at 45 degree angle from it. So put that down for me. And if I put it here, it would fit perfectly there, showing the face. So isometric sketches uses what? 30 degree angles. Oblique sketches uses 45 degree angles with the front face. So let me write the definition. should have these notes now on your paper. So you're gonna design your paper with these notes. Oblique sketching, right, has one view to which everything is projected from, and put in bracket, projected from, in bracket, 45-degree angles. You still don't see the picture? I'm going to give you another example over here. Everybody finish writing off the definition? Let me give another example quickly. Alright.
Yes, sir.
Let me give another example now. Let's say that I wanted to draw this ruler on the board, which is weird. Why would I want to draw a ruler on the board? So let's start off. I'm going to be biased to the face of this ruler. So all I'm going to do is draw a rectangle to represent the face of this ruler. And then now, the width of the ruler I'm going to represent with a 45-degree line going away from it. We call that receding axis. And I'm going to write word down. So the width of this ruler rather the width of this ruler is receding at a 45-degree angle. So, receding axis of 45 degrees on that ruler. Any questions so far? Any questions?
Sir, can you please go back to the notes?
There you go. And the final one, it's what you guys always do when your parents don't want to hear you out. You always say, just picture you in my perspective. Alright? So this one is saying, I'm going to draw based on where I am looking at the object. Okay? So we call this perspective drawing. So this is a note for oblique drawing. For isometric drawing, you already have the note. For perspective drawing, right here, perspective sketching, alright, for this one, I'm going to incorporate the use of the textbook that we're going to start using from now on. Okay, great. Can everybody see this bag right here? It's a lovely design bag.
Yes, sir.
Alright, so the angle to where you see the bag drawn here is if somebody was standing here. But let's say somebody was standing directly in front of the bag. Would they still see from this angle? No, they would rather see the bag facing front of them like this, right? Everybody see that?
Yes.
Alright, good. But it even goes further. And I'll show you how it goes further. But perspective drawing, alright, talks about viewing an object in different planes. Alright, try that. Viewing an object in different planes, like from the side, from above, viewing an object in different planes. From, in bracket, from one side, behind, in front, etc. Okay, so let me read it out. Viewing an object in different planes, in brackets, from one side, from behind, or in front. Okay. Alright. Now, with that said now we can quickly move on into the first type of sketching, which is isometric sketch. Alright? But let's create some differences between each. So read this for me quickly, Shirag.
Right, sir. A perspective sketch presents the most realistic looking view. It shows the object as much as it would appear in a photograph. Portions of the object that are farther from the viewer appear smaller, and lines recede into the distance.
Okay. Right, sadly I don't have a better perspective drawing to show you here, but I'll give you some examples soon. I think, okay, no, I don't have any sketches here. Yeah, here we go. So let's say you're walking down a hallway, right? Don't the tiles get smaller the further you look out? So based on your perspective, the tiles get smaller. Let me give you a perspective drawing. Hallway. Here we go. Everybody see that? Based on where you're standing right here, the tiles appear to get smaller the further you go out, or the further you look out rather. So that's what we really mean by perspective view, making it look more realistic. Okay? Now, axonometric is the same thing as isometric, right? So the same axis, and I want Isaac to read this for me. An axonometric sketch is?
An axonometric sketch is drawn so that lines do not recede into the distance but remain parallel. This makes isometric views easy to sketch but takes away somewhat from the realistic appearance.
Right. And the final one is oblique. I think I have an oblique sketch for you. Okay, no, I don't have an oblique. But an oblique sketch shows the front surface of an object looking straight onto you, alright? And it is easy to create, but the issue is that it looks less realistic because you can't see the depth of the object, which means any details that would not be seen in front. Alright, so here's what we mean by perspective drawing. If you look at an object at the side, the object looks tilted and the lines appear smaller. That's what we mean. Okay, so now with that said, we're going to start off firstly with isometric projection. Okay? Alright, now let's start off with isometric projection. Here we go. There's some key details you must understand. So what I want you to do, you're going to draw an isometric box or a construction box of any measurement, but make sure it's equal. So let me just quickly give you a sketch.
Will you draw with your ruler and stuff?
No, sketch it with your hands. Sketch it with your pencil. I said sketch it with your hand. Alright. Sketch it with your pencil. No rulers there. Okay, now here we go. Right, so the first thing you're going to do, draw a horizontal line to indicate your base. You're going to then draw a vertical line and draw it faint. I use blue to represent faint lines. I'm going to use white representing construction. 1 second. Probably use about that. Good? So, let's say that I'm going to go in this distance 30 millimeters. Don't actually draw 30 millimeters. Freehand sketch it. There you go. The same in the opposite direction. Then I'm going to draw a vertical line. Mine could have been a little bit straighter, but that's it. Here we go. It's going to hit back to the base. Back over there. Back there. Any questions?
Sir, how would you like get the angle?
Repeat?
Would you like get the angle?
How did he get the angle?
You use a instrument for it?
No, the angle, you are going to say it's at 30 degrees, but since you sketched it, you know it's not actually 30. But you do realize it's very close to being the same. So the angle really should be 30 degrees between here and here. And we're going to label this just to prove it. So let me draw my white line straight down. And we're going to label this drawing. So the very first labeling, after you've drawn your diagram like this, we're going to label what measurement we see in each box that makes it actually isometric or axonometric. At every axis it is equal. Let me show the diagram again. Okay? Alright. Now, you're going to sketch a little circle going throughout your isometric box. Why is the importance of the circle misunderstood? Diksha, if you add each section of the circle, what do you get? How many degrees do you get? What's 120 plus 120 plus 120?
360.
Right. So that means, right after me, let me show you the board. You're going to put on each face of an isometric drawing, you have 120 degrees on each plane, equally to draw. Right? So put that for me. Point 1. On each face,
You can have overlapping lines in this.
repeat that for me.
You can have overlapping lines in the editing one.
Right. Yeah. For now, because you're sketching, so let me just quickly finish this for you. Alright? And I'm going to say each section is 120 degrees. So label that for me. Let me use the orange for dimensions. So I'm going to say, let me erase this. Let me erase this as well. Let's put 120, 120, 120, 120, 120. So in this circular wheel, we each have 120 on both sides. So what I wanted to label this is front view, the end view, and the plan view. I'm going to call this FV, which stands for front view. We're going to call this E.V, which stands for end view or side view / side view. And then we're going to call the top simply the top view or the auxiliary, sorry, not auxiliary, or the plan view. Alright? We're going to call this the PV, which is the plan view. Alright? Because here's what my thinking is. For the past 4, 6 months, 5 months, we've been strictly learning calculations. It hasn't been a class where we just take a step back and appreciate what the components of drawings actually are. Because you did the isometric drawings, but I bet a lot of you guys didn't really understand what you were really doing. So that's why I'm saying we're going to take a quick pause and just appreciate the beauty of isometric drawings. So firstly, we say that each face is equal to 120 degrees. So you have a total of 120 degrees to play with. This is supposed to be 30, my bad. This is supposed to be 30. This is supposed to be 30 as well. And then in each degree we have 120. Now let's continue now. The next thing we're going to label is that the distance to the rest of this plane, if from here to this point is 30 degrees, then we only need 60 degrees to get back to the 90. So that's why we say it is equal to 60 degrees right in that section. Same thing for the opposite side, 60 degrees. Okay? Everybody understand? Clear, everybody?
No, sir.
Oh, you said no? Alright. Where did I lose you?
Can you explain?
Alright, so how do I explain the 60? Is that what you're saying right here?
Oh, that's it.
Yeah, because if I was to be biased and draw just the square, quickly look at this one now. If I was to draw just the square, each side in the square is 60. 60 plus 60, that was how much? 120, correct? Hello?
Yes, sir.
Let me show you on the screen. Probably my screen is blurry. Let me show you on the book again. Alright? So the entire side right here is 120. The distance between this line down here is 60. So therefore, if you add 120 plus 120 and then you add the next two 60s, that would give you your 360. Let me show you what it actually means. So I'm going to draw this box over here so you can see it better. Look, everybody, stop what you're doing and look for me quickly. This is what we actually have. Because we're drawing in an angle, normally each side would measure 90 degrees, right? Agreed? Normally each side in a square would measure 90 degrees. But because we're drawing in isometric, we're saying that because this is tilted, you're going to get 120 degrees right here. Okay? And because this is tilted as well over here, you're going to get another 120 over here. So if I've taken 120 plus 120, how much degrees do I have left to share between these two? Isn't it 120?
Yes, sir.
Right. So these get smaller as a result of these expanding, and this turns to 60 degrees and 60 degrees. And that's how we have an isometric square. Alright? From this full square, which is 90 degrees on each side, you have an isometric square, which has two sides equal to 120 and 2 sides equal to 60. Okay? That's the real premise behind it. Now, what I'm going to quickly do now is get into the drawing aspect. We've explained the axis now, but let's quickly understand how to do this type of drawing. We call this a non-isometric line. Why is this so? Can anybody tell me? Remember, this is the isometric line where each line is parallel. What is the difference between this line? I'm going to ask somebody I haven't heard from, Abigail. By the way, before you answer, I need to see some cameras on. Christoph, Cameron, Abigail, Talia, Dimple, Mr. Thompson. Oh, that's me. I need to see some cameras on. That was a joke, guys. Come on. This is TD. Come on, smile. Christoph, where are you? There you go. There we go. Alright, that's Mr. Thompson and Dimple. That's me. Let's go. Abigail. Non-isometric lines. What does that mean? The term none means no. So if I have no in that regard, what is it saying about this line therefore? It is not?
It's not parallel.
Yes. Give her a clap. It's not parallel to the isometric lines. Look at these two lines. This line is parallel with the line up here, and this line is parallel with the line across here. This line is parallel with the line across here. This line should have been parallel with this line, but as you can realize, it is not. So we call it non-isometric. Okay? This is the first drawing I wanted to complete today. So I'm going to give you the measurements to complete it. Alright? The measurements of this side. Let me draw on the diagram quickly. The measurements of this side, we're going to say is 20. And this is just me sketching, to be honest. Alright, there is no measurement, but I'm giving you some measurements to use. So you're going to say this side is 20. This
That's
is...
it for measurements.
Repeat that for me?
For measurements, can we use like rulers to like measure out the distance?
Yeah, but now you're going to draw it for me now. So all I've been sketching, but I want you to complete this drawing for me using some measurements I'm going to give you. So we're going to say this side is 20. Let me write on the board because that PDF is slowing up. Can everybody hear me? Yeah, my laptop is... Alright, that PDF is way too huge. Okay. Let me give you your measurements you're going to use. Alright. So look at this one now. The side going across here. Oops. The side going across here. That's 20 millimeters. Going up. That's 50. On both sides. Okay. Let me screen share again. So that's 50 by 20. 50 by 10. Let's say 10. 50 by 10. Alright. Let's check if I can draw back on this PDF now. Good. Good. Here we go. So this is 10 as I said. Let me draw here. Can anybody see my screen?
Yes, sir.
Alright, good. So put that for me. This side is 50. This side is 20. This distance is 10. This is still 50. Okay? The distance from this point to here, I don't know why I'm not able to draw on this PDF. Alright, let me just sketch it on the board. So pay attention for me. I'm just going to sketch it on the board since I can't draw on the PDF for some reason. Alright. So that's 50 by 20. Go out a little bit more. 50 by 20. Alright? Then you're going to have a distance going across. Let me start again. 50 by 20. Okay. Then you're going to have a distance going across of 70. Okay. And from here, connecting back to this point, that's 70. That's 70. And then from this point going all the way out here, that's another 70. And then the distance from these 2 points going up, that's 10. So we're going to go up 10. You're going to go 50 up, and then you're going to connect these 2 points, connect the bases as well. Alright, somebody have Wi-Fi issues. Alright, so let me give you the measurements again. 10, 50, 70, 70, 50, 20, and the entire length here, from here to here, is 60. From here to here,
Sir, do we use ruler with this?
repeat?
Do we use ruler with this?
Yes, you're gonna use a ruler for this.
Alright, so can you move the camera? Some of it isn't it.
There you go. Alright. That's your homework. But for some persons, I know you're past the stage since I've given you drawings to do that are more complex than this. So when you finish this, right, I want you to try and complete this drawing as well. Because remember I said we're going to start off the class and I showed you this drawing. Who can remember this? Some sketching exercises. You're not going to use any measurement for these. I want you to sketch B, C, and D and make your drawing as accurate as possible. Clear? B, C, and D along with this one that I just gave you for homework. You're going to practice sketching for these 3 and then actually drawing the one I just gave you for homework. In future classes we're going to practice these, but I want to make sure you get started off properly by learning those 3. So let me take a picture of it quickly. Alright, now at this point I'm going to ask everybody, what are your career paths? Because I want to know, I'm going to give you some activities to do that are really geared towards your career path. So for example, Shirag, what do you want to be in the future?
Surgery.
Surgery. Alright, let's go down. So let me write it down. Because I want to give you a research activity to sketch something that is in surgery, right, for each of your career paths. That's going to be due at the end of the week though. 1 second, let me just, alright, let me type it here. Alright, so Shirag, surgery. Isaac, what do you want to be?
Anesthesiologist again.
Can you repeat that for me?
all the jiggers there.
On a straw. Alright. If you guys don't feel comfortable telling me, you can type it to me. Alright. I get a feeling that you guys are very shy like that. So if you don't want to tell me, you can just send it to me on WhatsApp or on email. But I need them. So private message me what your answers are. Just private message me quickly what your answers are. What do you want to be in the future?
Sir, do I need to email mine yet?
No. I wrote on yours. Alright? But for the others, I don't want to get your business out of there. So just tell me in private chat so I can just quickly write them off. Alright, waiting. So you have a minute left to send it off. So in the meanwhile, take off this drawing, begin this drawing. Make sure you have your construction lines separated from your main lines and you dimension your drawing correctly. Still waiting on those messages. Only one person so far. Alright. So, here's an activity we're going to do now. Everybody look at this. This is an isometric drawing, right? Measurements and all. What I want you to do, you're going to sketch how you think this will look in oblique. Yes, I know. Let me start it off. How would we sketch this drawing in oblique? First of all, we need to know where we're looking from, because oblique says we're going to choose a face. Right? Because remember, this is really what we have. Right? Oblique says you're really going to choose a face, look from it, and everything else is going to be a 45-degree angle. So let's choose this face. Agreed? Alright, so final activity for the day, as I was saying, we're just going to sketch this in oblique. So let me just quickly disable the waiting room. There we go. So this box represents this area right here. Alright, this is what we have so far. Let me make it a little bit more accurate. Good. I have a lot more area to draw. I have this region to express. So how would I express this region? Well, firstly, I would need to explain that even though I'm looking at the front, these lines are not on the same line here. They go back. So what you're going to do? Indicate that to me. How much do they go back by? Let's say when you finish drawing, you measure it and it is 70. Draw how much it goes back. Clear? Alright? And then you're going to tell me where it stops. It goes back and stop here. Okay? So once you told me that it stops here, then you're going to project everything back at a 45-degree angle. So this line over here, we're going to project at a 45-degree angle. Alright, we've only sketched here and here on this drawing. We're going to project everything else back at a 45-degree angle. So let me use another color. And I want you to take this off for me. You're going to finish the sketch. So a 45-degree line, let's say it looks a bit like that. Well, that is very odd. Let me try again. There we go. That's the first 45-degree line. The next 45-degree line comes from the fact that your drawing, let's say, stops all the way out here. You're going to now tell me, what do you think we're going to do to complete this aspect? Alright? So that's the next section we're going to complete next class. So I'm going to take a picture of it. This is the homework you're doing in isometric. And you're going to finish now this sketch I've given you that is in oblique. What do you think is going to happen for this section right here? Clear, everybody? So you don't have to draw, you're just going to sketch it on a piece of paper. We must submit it with your homework. And next class we're going to go through it together.
Wait, sir, so what are all the works then? Again, well, we have to draw this.
Alright, let's go back. You're going to draw this. Then you're going to complete these three drawings, B, C, and D. And then you're going to finish this sketch. So a lot of small drawings you have to do.
Alright, sir. And the only one that we use ruler with is
this one.
The measurements.
Yeah, this is the only one you're going to use with ruler. Every other drawing you're going to actually just freehand sketch, but make sure they look realistic and proportional. Alright,
sir.
I'm going to post it on the portal, but that's it. If you have any questions, do message me with your job field so I can design a research for you that's going to make you more interested in whatever path you want to go in. Alright, everybody?
Yes, sir.
Alright, but for this one, this is going to be the most difficult one. You can look on Google how oblique drawings look. You can look in the textbook how oblique drawings look. Let me show you before you go. Quickly, let me just give you a quick sketch of an oblique drawing that you can just reference to predict how the one I just showed you looks. So let's go here. Let's look for oblique drawing. Alright, here we go. Oblique sketches, page 98. Here you go. Here's some examples of oblique sketches. So the face is shown first, and then everything is projected at a 45-degree angle. Okay? Right. So I'll send you the textbook that you can scroll through and try to predict how this drawing will look in oblique. Have a great day, everybody. I'll see you tomorrow.
Thanks.
Thank you, sir. You too.